All right. So when I say a matrix, it looks something like this. It's just an array of numbers. Maybe I should get a little more. So these can be used in a lot of different scenarios. One situation is with systems of equations. They can be used, and there is actually a process you can use matrices to solve a system of equations. But they're really just used to organize data anytime you have a lot of data. So like computer science has a lot of matrices in it. Any career that involves a lot of different data, this is used to organize it. For your purposes, we're just doing the basics. Okay, so we have rows and we have columns in our matrix. Things are equal if they have the same number in the same position. So even if I had taught you absolutely nothing about matrices, if you guess, I can just about guarantee you would get the right answer on this. What do you think variable x would be if I want to make matrix A equal to matrix B? 2. What do you think variable y would have to be? What would p have to be? And q would have to be 0. So they're equal if they have the same numbers in the same positions. That's it. Nothing fancy. So, with a matrix, it's just an array of numbers. You can have positives, negatives, fractions, decimals, any of those things. Your rows are horizontal, columns are vertical. So if I look at this, that represents a row. If I look at this, that represents a column. If I ask you for the size of a matrix, it's just row by column. So how many rows does this matrix have? 2. Rows are horizontal, so we have 2 horizontal by how many columns? 3. So this is a 2 by 3 matrix, 2 rows and 3 columns. For basic operations, adding and subtracting, you can do as long as the matrices are the same size. So they have to have the same number of rows and columns. Otherwise, you wouldn't be able to solve it. So if I ask to find the sum and difference here, what's the size of matrix A? 2 rows and 4 columns. What about matrix B? 2 by 4. They're the same size. That means we can add and subtract. Our answer will still be 2 by 4. That doesn't change. So if I said A plus B. Again, if I don't teach you anything, you could probably guess and get this. What do you think the first number in A plus B would be? -1. You just add the corresponding numbers. So 2 plus -3. The next number I'm going to do, 4 plus 4. Next one, 8 plus 0. Last one, -3 plus 1. What about the second row? All right, take a second and try A minus B. Subtract corresponding numbers. So 2 minus -3, 4 minus 4, 8 minus 0, negative 3 minus 1. Second row, 0 minus 6, 1 minus 8, 2 minus 2, 3 minus 0. All right, so can everyone in here add and subtract matrices? Okay. We can also do combinations. We can do like multiples of a matrix. So let's take a look at what I mean by that. So I'm going to ask some questions involving these three matrices. Just for practice, what's the size of matrix A? 2 by 3. B? 2 by 3. C? 2 by 2. Good. So if you had to guess, what do you think I mean by 4A?
Everything in the matrix times 4.
Yep, every single number times 4. You get 12, 4, 20, negative 8, 0, 24. What about 1/3 C? So 1/3 times 9 is 3. 1/3 times 0 is 0. 1/3 times -3 is -1. 1/3 times 6 is 2. Okay. We can do combinations. So 3A minus 2B. You might just be able to write down the answer here, and that's totally fine. I'm going to take a minute and just show what we're doing here. So if I said 3A, you take everything in A times 3. You get 9, 3, 15, -6, 0, 18. Minus, what's 2B going to give me?
8, 2, 0, 16, 2, 8.
So we did the 3A, we did the 2B. Now we just go through and subtract. So 9 minus 8 is 1, 3 minus 2 is 1, 15 minus 0 is 15. -6 minus 16 will be -22. 0 minus 2 is -2. 18 minus -6, so 18 plus 6, 20. Is that okay? Multiplying matrices is the one thing that's different. Well, multiplying and dividing, but we won't do any dividing. To multiply a matrix, you actually don't just multiply corresponding numbers. So what happens is when you take a row times a column, we get a single number for the answer. So we go through, you take a row times a column, you multiply the corresponding pieces. So 3 times 3 is 9. -5 times 4 is -20. And 2 times -5 is -10. And then you add those numbers together. So that gives me -21. So when you take a row times a column, you get a single number, multiply the corresponding pieces, add them together. So this is probably the only rule I'm showing you today that you wouldn't just know what to do if you guessed. This one's different. So that's what we're going to spend the majority of our time on, is talking about how to multiply matrices. Questions? I'm actually just gonna skip to this. So first we have to make sure we can multiply them. To do it, we have to be able to take a row times column. So before we multiply, I want you to write down the size of the matrix. What is the size of this first matrix? What's the size of the second one? Okay. To check to see if you can multiply, the number of columns in the first one has to equal the number of rows in the second one. So basically when you write these, those numbers have to match. Would I be able to do B times A? No, B is 3 by 4, A is 2 by 3. So could I multiply B times A? No. So unlike other multiplication, order matters here. So the middle numbers have to match. That tells me I can multiply. To figure out the size of the final answer is going to be given by these numbers. So my final matrix is going to have 2 rows and 4 columns. Okay. So this is my setup. We had to make sure we could multiply them, and we know how big our final answer would be. Is everybody with me here? To do this, you have to take a row times a column. Okay, we are going to get first row 1 in this matrix. To get row 1 in my answer, I'm going to use row 1 in my first matrix. Okay? And I'm going to take it times each of these columns. So first, I'm going to do row 1 times column 1. So if I multiply this, 2 times 2 is 4. 4 times 4 is 16. -1 times -3 is 3. If you add those together, we get 23. That is my first answer. Is everybody okay with how we got that one? You guys in the corner okay back there too? Will, you with me? So, the next one. I'm still working on row 1, so I'm still using row 1, but I need the second column. So I'm going to take the first row times my second column. We multiply the corresponding numbers. So 2 times 5 is 10. 4 times 8 is 32. -1 times 1 is -1. If I add those together, I get 41. Now I need the third column, so I'm doing my first row times my third column. So 2 times 1 is 2. 4 times 0 is 0. -1 times -2 is 2. I add those together, we get 4. Last one, first row in the fourth column. So 2 times 4 is 8. 4 times 6 is 24. -1 times -1 is +1. So we get 33. Have I lost anybody here? That's the first row. How do you think we get the second row? I take the second row times each of those columns. So 5 times 2 is 10. 8 times 8, 64. Oh, sorry. I looked at the wrong row, didn't I? Let's try that again. Okay, so I'm on the first row, or first column. 5 times 2 is 10. 8 times 4 is 32. 0 times -3 is 0. So we get 42. It's not that the math is hard here, it's just there's a lot of room for error if you miswrite a number. Alright, second one, 5 times 5 is 25. 8 times 8, 64. 0 times 1 is 0. So we get 89. Third one, so 5 times 1 is 5. 8 times 0 is 0. 0 times -2 is 0, so we get 5. And the last one, 5 times 4 is 20. 8 times 6 is 48. 0 times -1 is 0. And we get 68. So you take one row at a time, multiply it by each column to get your values. What questions do you guys have right there? We're just going to practice this until I feel like we've got it. Okay, this was the final thing for today. So, if I ask you to find this product, first we have to make sure we can do the product. What's the size of the first one? What's the second one? So can we multiply them? Yes. How big will my answer be? 2 by 4. So I know my final answer is 2 rows, 4 columns again. So we start with the first row. Row 1 times column 1. 2 times 2 is 4. -2 times 3 is -6. 4 plus -6 is -2. Second column, 2 times 1 is 2. -2 times -1 is 2. 2 plus 2 is 4. Third column, 2 times 4 is 8. 2 times -3 is -6. 8 plus -6 is 2. Fourth column, 2 times 6 is 12. 2 times -2 is -4. 12 plus -4 is 8. Then we repeat with row 2. So 1 times 2 is 2. 0 times 3 is 0, and we get 2. 1 times 1 is 1. 0 times -1 is 0. 1 plus 0 is 1. 1 times 4 is 4. 3 times 0 is 0. We get 4. 1 times 6 is 6. 0 times 2 is 0. We get 6. Is that okay? Think you guys can try one? The first one's 2 by 3, second one's 3 by 2. Middle numbers match, so they can be multiplied. Outside numbers 2 and 2, so we're looking for 2 by 2. So you start with the first row. First row times the first column. So we get 1 plus -2 plus 6, so 5. First row, second column. So 2 plus 0 plus 12 is 14. Second row, so second row, first column. So 0 plus 1 plus 8 gives us 9. Second row, second column, so 0 plus 0 plus 16 gives us 16. How do we do? Good? Let's do last one. How big is this one? And this one? So can we multiply them? Yes. If you couldn't, you just say no solution. And my answer will be 3 by 2. So 3 rows, 2 columns. So we start with first row. First row times first column. So 1 times 1 is 1. 0 times 6 is 0. 1 times 8 is 8. So we get 9. First row times the second column. You with me, Zach? So 1 times 3 is 3. 0 times 2 is 0. 1 times -1 is -1. And we get 2. All right, you guys tell me, what do I do next? Second row, first column. So 2 plus 24 plus 8 gives us, okay. Then second row, second column. So 6 plus 8 plus -1. 13. Now what? Third row, first column. So we get 3 plus 36 plus 8. And third row, second column. So 9 plus 12 minus 1 is 20. Any questions for me? There is a handout